GCSE Physics boosters, transformers. What are transformers? What do they do? How do they work? Now, transformers come in different shapes and sizes. Top left, you might find something like that inside a washing machine, something which has a powerful motor. Top right, something like for a computer or an Xbox. Bottom left, that's a big beefy transformer. That one, you might find that near a power station. And then bottom right, that toroidal transformer, it's called, that's the power supply of a computer, would have one of those in. So what do transformers do? Well, basically they make an AC voltage bigger or smaller. So they can make a voltage bigger, that's called a step-up transformer, or they can make a voltage smaller, and that's a step-down transformer. But they only work with AC, okay, an AC voltage. They don't work with DC, and you should realize why later. Basically, you've got an iron core, and you've got two coils. One of the coils is the primary coil, that's where the voltage goes in, and the other coil is the secondary coil, that's where the voltage comes out. So an iron core, this is an iron core. Why iron? Because it's a magnetic material and it's going to get magnetized and demagnetized. Okay, so iron is used because it's a magnetic material. Now what I've done here is I've added a coil to the iron core. I'm calling this the primary coil. It's the first coil, and I'm putting a voltage across this coil so that an AC current is flowing in the coil. And because we have an AC current flowing in it, this is going to produce an AC magnetic field, yeah, an alternating magnetic field. Look at the blue arrows. The magnetic field goes one way and then the other way and then that way and then that way with a frequency of 50 Hertz usually. So you've got magnetism sloshing around inside the iron core, a magnetic field that flows backwards and forwards inside the core. Now we add our secondary coil, okay? And this secondary coil, remember the generator effect we've talked a lot about in the last couple of videos. And because of the generator effect, we are going to get a voltage induced in this coil. Okay, and it will be an alternating voltage, an AC voltage. If it's connected to a circuit, like if we connect the secondary coil to a bulb or a resistor or whatever, then we'll also get a current induced. And this is how a transformer works. And you need to explain this in an exam. Okay, how is an AC voltage induced in the secondary coil? So make sure you can explain it. Now, the output voltage depends on a couple of things. It depends on the input voltage, what voltage we put in, and it depends on the ratio of the number of turns. Okay, the number of turns on the primary, I'm going to call that NP, and the number of turns on the secondary, I'm going to call that NS. And what's important is the ratio. Now, look at this data. I've got voltage in, I've got voltage out, and I've got the number of turns. What patterns can you see? Can you figure out how we work out the output voltage? Okay, pause the video and have a think, look at it if you don't know. And basically what you should realize is that if the number of turns is getting bigger, then the voltage gets bigger. If the number of turns is getting smaller, then the voltage gets smaller. Yeah, I've just said that. If the number of turns gets bigger, then so does the voltage. If the number of turns gets smaller, then so does the voltage. And if you look on the first one, the number of turns there is 20 on the primary, 60 on the secondary. So basically it's going up by 3 times. And what's happening to the voltage? Well, we're putting 10 volts in and we're getting 30 volts out. So it should be pretty obvious what the pattern is. Now, this equation, you'll be given this equation. If you want to rearrange it, then you're very, very welcome to work out this, that, and the other. I think it's easier just to remember that the ratio of the voltages is equal to the ratio of the turns. So P is primary, S is secondary, and this term here, NP over NS, if you multiply that by V in, that will tell you what V out is. Let's look at an example. A transformer is used to step down 240 volts AC. If the primary has 480 turns and the secondary has 24 turns, what voltage will it provide? What will V out be? Well, have a go yourself. I'll show you the answer in 3, 2, 1. Okay, so looking at the number of turns, 480 to 24. So the ratio is 20. So the voltage will be 20 times smaller. So 240 divided by 240 divided by 20 equals 12 volts. Here's a couple more examples for you to have a go at. Pause the video, pen, paper, calculator, and I'll show you the answer in 3, 2, 1. There you go. Lastly, this is what I'm going to talk about in the next video, because this video is getting a bit too long anyway. Now, a transformer can change the voltage. It can make the voltage bigger or smaller. It can also, in fact it does, it changes the current as well. Now, how does the current change and why is that important? We are doing that in the next video.